Hi guys, this is Nitin, and in this video you will see that I am controlling my PC remotely. So this is a small web app which is running on a ESP8266 microcontroller, and as you can see I am now pressing the power button so that I can turn off the PC, but it is selecting the text so the button signal is not sent over. I will try it again, this time by carefully not clicking on the text. Now you can see the button status is green, which means the signal is sent and the PC is forcefully shut down. As you can see, the PC is completely off. Now let's try to turn this on again. So I'll just press the power button and the PC received the signal, and you can see the PC has turned on now. Oof, that was some really rough demo, but I'm improving upon it. But you get the idea what I'm trying to achieve here. So I have this small web server running on a ESP8266 module, also known as Node MCU, which acts as an virtual power button which I can control remotely over Wi-Fi. And even if I'm not at my home, I can use VPN to connect to my network and again access the switch. So the goal is that whenever I have my PC to be turned on or off, I can use this. Although for turning off, I have better ways like using SSH to send the shutdown command, but I cannot turn it on again. So that is where it shines. I'm going to talk about the hardware aspect as well as the software aspect of this project. But before that, let me tell you a small story why I actually wanted to build this. See, I installed a 6 kilowatt solar power system at my home, and sometimes due to bad weather or some reason the battery is not able to keep up with that. And if I have a lot of demand in the office or in the home, then I am very certain that in next 1 hour my PC is going to be shut down or interrupted. But I really don't want that, and that is the main reason I wanted to have a way so that I can send this shutdown or turn on signal to the PC while if I'm not around, I can't reach to the power button of the PC, so I wanted to do it remotely. Now, previously I used to send shutdown command using SSH from my mobile using the Terminus terminal application. But if I want to turn it back on, that was quite the challenge because I will have to call someone to go and then physically press the power button. And that is quite challenging and not feasible all the times. So that was the main reason why I wanted to build such a project. And I'm not just sending the state like, hey, turn on the button and then it keeps the button on. Instead, it works like something in real time. So as long as I have my cursor pressed onto the button in the web browser, the button is pressed on the PC side, and as soon as I release the cursor, the button goes off. That is the primary purpose. So now let me talk about the hardware part of it, how the connection works and what components you require if you want to build something like this for your own. So I have this small sketch drawn here in Excalibur, and on the left I have a ESP8266 module which is in actually taking power from the motherboard itself, so I don't have to deal with a separate power source because the motherboard keeps on powering the ESP8266 even if the system is shut down. So I just use a multimeter to tap onto different locations which is available on the motherboard and see in what cases the power is actually available and at what voltage. Ideally, I wanted to have 5-volt power source, and I luckily found this demo or DLED1 port which had those configuration. So this is how I'm powering on the ESP8266 module. Now I'm using a relay here so that to simulate the physical power press button, and on the motherboard header pins here you can see I was able to read the prints which says which pins belongs to power button and which pins belong to the power LEDs. So what I have done is I have basically used the D1 and D2 pin on the ESP8266. D1 is to read whether the PC is on or off using the power LED state. So if the LED is on, it has like 3.3 volt available at that point, and I'm just reading that. And to not put damage to the ESP8266, I'm also using a 1 kilo ohm resistor there. But the problem which arises later is if the PC was on, it is still not able to detect it because of the small current flowing. So I have to add a 10 kilo ohm resistor between the ground and the D1 pin so that whenever the PC power LED is off, it should go completely off because I'm reading the binary values here. So I wanted 0 or 1 values so that I can be sure that the PC is either on or off. And I am just using the D2 pin for sending the signal to the relay switch. And on the other side, normally I keep the relay switch as closed. I mean, the power button should not be pressed at that point. And when I send the signal, and that is on the signal pin of the relay, it connects internally the coil and the points which is connected to those coils. I am using those as a point to simulate a virtual button press on the motherboard. And this is how the whole system works. Now let me just show you the web app first, how it looks like and what features does it have. So it's a very simple one, and if you load it for the first time, it might not show you the logs. It only shows the PC status and button status. Right now if you see, this is red because it takes some time to connect, but if the PC is on, it will turn on green. And by the way, when I press this button here, it's not like I am updating the color in the web directly. Instead, the signal goes across and it is pushed by the ESP8266 through the WebSocket to this server to actually show that the button is pressed. So no false information. If the connection is broken, if I and at that point if I press the power button, this will still be red and not turn green, which means the signal is not sent, which means the button is not pressed, and I will certainly know that. I also have this log here, so whenever something changes on the PC side, I immediately receive it. And the good thing is, because this is WebSocket based, so if I have connected this from multiple locations, let's say from my phone, from my laptop, or maybe in 2 tabs, so if I do something on one tab, the same information will be repeated and broadcasted over all the connections. So uh, basically, if I press the button here, the button status will go green, but it will happen on the both of the tabs, not on one of the tabs. So this is how it works. Basically loads a web app through HTTP server, and then all the communication happens over WebSockets. So this was all about the web app, and let me know in comments if you like the UI, if something is missing, if I can improve something upon it. Now let me just quickly show you the Arduino code for it. So I'm not a pro at writing C++ or Arduino based programs, so I used ChatGPT, but I certainly knew what I wanted to do and have some basic idea about how to program microcontrollers. So I have also put a small diagram here so that if if I or if someone is reading the code, they will have some idea about what pins does what and how the components are connected. This is a small list of components, so I don't think this will be very difficult to figure out. But here what you actually need to change is you will need to change the SSID and password so that the ESP8266 can connect to your Wi-Fi network. And there is also one thing which I smartly use, which is called MDNS. So I have defined the host name here. You can put in anything. And basically, when you will visit this address, whatever the hostname that you defined in the code, for me, I defined Luna-button. So I don't need to remember or discover the IP for this Node MCU microcontroller. Instead, it will automatically broadcast its host name, and if your Wi-Fi is smart enough, it will be able to pick that up, and you will be able to use this host name to directly load the web app instead of going to find the IP and then loading that. I've also added some fail-safe mechanism. For example, it will reconnect to the Wi-Fi and it will keep on checking the connections. If the WebSocket connections drops, it will also reconnect the connection both from the client side as well as be available to do it from the microcontroller side as well. And finally, at the last, we have the whole web application code. This is tedious to write in one go because it is raw CSS, not Tailwind. I could have utilized Tailwind, but that would certainly depend on the internet to load the package. So I just used ChatGPT's help and wanted to have a basic web app which does all of these things. So this is what is loaded in your browser when you first load the URL, and then it keeps on communicating with the WebSocket to turn on the button or turn off. I also have this toggle and long toggle kind of endpoints, which I plan to use in future when I have some automation. So I can just ask Alexa to turn off the PC and to send a long toggle command, which is long press the power button for like 5 seconds, and it will turn off the PC automatically just with a single send command from HTTP. So it doesn't have to be there, press the button over WebSocket, keep waiting while pressing the button to do that. So this is all about the video, and I hope you enjoyed it. I tried to put a lot of effort and took into consideration the conveniences which I wanted to have, so that even if I'm not present there physically, I should have the idea that I'm able to control the PC based on what I wanted to do. So please interact with the video, please do like the video and add your suggestions in the comment. I always read all of those comments and also try to reply to those, and I will meet you in the next video.